Luna? Hey, Luna. Let's see. What do I have left? Uh, tu- 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 tu. Hmm. Okay. Okay, let's get to work. Jumping the gun here. Let's see. Where are we? Right here. We're right here. Any set of outer measure 0 is measurable. Mm-hmm. Hmm. This is the same. Mm-hmm. Okay. Hmm. Hey, Steph. Hope you're well too. How are you doing? You still working? Probably are, huh? Just working like a sad old man. I know how you feel, man. I know how you feel. Every time you come in, I always remember. I always remember I need to play. I always remember I need to play Magic. Holy shit! My friend has stopped inviting me to play with them. SNC2 is measurable. You're gonna be playing some this weekend? So excited! Nice. I need to play some more. Oh, I'm like, so I can obviously play on the on what's that? What's that? On Magic. That software called. Holy moly! What is it called? Oh, Arena. I could obviously play Arena, but I don't feel like I don't have any cards. I feel like I don't have any cards. I just have like the basic stuff. I never really put in the time to like farm the cards. Guess the advantage of playing Magic in real life is that you can buy individual cards. I wondered if you know, maybe I already asked you this. I wonder if you know my friend. I don't know if the community is like that connected in SoCal, but I'm curious. Let's see, intersected 2. Ba-da-bum. Okay, I need an extra page. Meh. And then, where was I? This goes here. Note that. My handwriting is atrocious. It's a union, not an intersection. What am I doing? That is a union. Okay, I should scroll to what I'm actually working on. Where am I? Where am I? Right here. Am I right there? I actually don't even know. Where am I? Heck? What's happening here? Oh. Hmm. Okay, the definition of measurable sets is here. Oh my god, they added stuff here. Okay. Oh my gosh, there's so many changes. It's no wonder I'm like confused. Okay, they added this. And what else did they add? This is still the same. Yeah, this is still the same. Translation. Is that even in here? That's in the last section. So it's like into this section this time. Any the translate E plus C of a measurable set is measurable. Okay, no, that's different. That is different. That is different. Oh my. Okay, there's a lot of changes in this book. The union of finite collection of measurable sets is measurable. That's this one. I'm working on this one. Oh, they didn't even do the induction. Interesting. Did they do it here? Wow, there's so many changes. Okay. Holy, the way they do it looks different too. Oh no, that's the same. Oh my. Just write the intersection. What the heck? Okay, so it's the same, sort of. It's the same argument. Okay. Okay. Thus. Why did I stop to look? I completely forgot why I was looking at the book. Okay. Whatever. Oh, why is my writing like this? Maybe I should practice. So hideous. Okay, let's put this here instead. Okay, what's going on here? This is by the distributive property. Oops, writing too much. This is just set. This is just a set fact. Another set fact. Or, I mean, I don't really have to say it like this. You can show that E1 E2, union E2 is a subset of X. Yes. Yes, yes, yes. So, just so it's clear, just rewrite it. I don't want to write this again. It's equal to this. Okay. Okay. do this because I want to reference them, so I might as well just identify what they are. Let's call this 1. And we're going to call this one 2. So by 2. Oh, my handwriting, no. By 2. And result 2 points. It's countable subadditivity, but what is the result? Countable subadditivity. There it is, 2.8. 2.8. Write this. This is just equals. We're just rewriting the set. Oh man, why is my writing so awful? Okay. No. Which is less than or equal to A intersect E, 1. A intersect, I guess I'll write it like that. A intersect E1 complement intersect E2. So that is by 2 and 2.8. Okay. Let's see. Did I skip something? Oh, I did. Holy moly. I skipped something. Shit. I did this. I gotta shift everything down. so many substitutions. I might as well just name everything. This is 1. This is 2. This is 3 now. This is 4. Okay. Paste. Maybe this deserves its own equation identifier. Maybe. We'll find out. We'll find out. Okay. This was 2. This was 3. Might as well. If I were to do this on LaTeX, it would handle it very easily. Okay. Okay. Um, 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 um. Okay, so we're basically using 4. No, not 4. 6. This is 4, 5, and 6. No, not 4, 5, and 6. Using. Okay, now my thing's frozen. What the heck? Why? Why are you frozen? Okay. Okay, using 6 and 4. On which one? On 3. What in the world is going on? Okay, this is okay. What did I just do here? I just replaced this. This is 4. This is 6. Okay. It's the base case. Why are you doing this? Gosh. Am I writing this correctly? Oh my. It just times out, huh? Interesting. What is that? Come on. Okay. Okay, since the base case isn't true and ooh. Wait a minute. I guess it doesn't matter, but it's not P that needs to be. It's not the index that needs to be changed. Oh my. This is P. This is supposed to be P. P plus 1, P plus 1. Okay. Oh man. This is P, this is K, this is P. This is also P. Okay, I'm almost done. I think I fixed everything. P, 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 P. Okay, I think that's it. Implies for a set of measurable sets, blah, blah, blah. Okay. What the heck? What happened? Oh my god. Oh shit. Oh man. Okay, what the hell did I put here? This is 2. What happened? Man. Good thing there's a VOD. Let's see. Okay, where do I go? Too far. Okay, where am I? Base case. Okay, I found it. I found it. I found it. I don't know how this got deleted, but whatever. Substituting. Substituting. 2 to 1. Just E1 complement. Intersect E2 complement. Okay. And then oh, what the heck? Oh, what happened? Okay. Okay, okay. Is there any way I can fix this? This is so stupid, man. Why? Why are you doing this to me? Man. Okay, let me try to grab it. There's no way I'm gonna be able to. Shit. Yeah, there's no way I'm gonna be able to. This is so troll. It's gonna rewrite everything thanks to this application that doesn't want to work. Okay, so I wrote this. Student note that also. Okay, so this is still good. And then this is where it goes to shit. Let's see. I did label this. This was 3. This is 4. This is 5. Okay. Maybe I can save some of this stuff. Okay, so delete this. No. This is so annoying. Okay, I can't save this. Five, 5. What is this? Okay, this is 6. This is 6. Okay. See 4 and 6 on 3. Okay, we're almost there. Like, too nervous to copy and paste now. I think it's the copy and pasting that's ruining it. It's for E1, union E2. This is by 4. Okay, I think I fixed it. Hopefully. Shit, man, that was so annoying. The heck? Didn't I write by induction? Huh? What the heck? I swore I wrote by induction. There's no way. I did. Oh my gosh. What is going on with this application? Oh, now I'm worried about writing induction again. Because it's probably gonna do the same thing where it writes over uh, something else. Oh man. So stupid. Why? Why are you doing this to me? Whatever. If it writes it over, it's probably gonna write over the same spot. Induction. Okay. What else do I have? Oh, so much shit that I did. What does the book have? Okay, we did this. We did this. I guess we can do this. We did this already. We haven't done this. I guess we could do this because this is not too bad. Should probably be done before. Actually, it doesn't really matter, but like, doesn't really depend on unions. So it could be done before. Yeah, but it doesn't matter. Whatever. I don't want to move things around because it's probably going to like have that same problem again. So let's just call it result 13. So we're going to do the set difference one. Did I not already do this already? Wait a minute. Am I tripping? Was this in the last section before? Set difference. I feel like this is... Let's see. No, it isn't. Interesting. I feel like this result should be in the last section. Or maybe not, because it depends on it being measurable. I see. Okay. Let's do that then. I hate this notation. Hmm. Ooh, that's actually pretty clean. Wow, that's a very quick proof. Interesting. Basically get it for free. I guess expand on it a little bit more, because it's sort of obvious, but maybe not to some. intersect E naught plus the measure of E intersect E naught complement since E is contained in E. Furthermore, to it's equal to E intersect E naught complement. And so we get the desired result. Okay. That was pretty cool, at least. Surprised it's not in this book. Oh, it's in the next section. It's not even a property in the next section. It's just like a random fact that they state. Wow, it's so crazy how many changes there are from the 4th edition to the 5th edition. Okay. All right, so that one's done. Gonna do the other quick one, the translation one. Okay, that one is. These are also quick. This is not in the book. These are just ones that I thought of. So I can just list them here so I don't have to take a page. So let's list them as 2.14. And 2.15. Okay, I think it's fine. Is there anything else? Oh, this one I do have to do something before. The union of countable disjoint collection of measurable sets is also the union of countable. What the heck? Why did I write that? I must be fried. It's probably better to write it like this instead of disjoint collection. A collection of disjoint measurable sets. Yes. This one should be move this here. Okay. Let's see. Let's see. Okay, I guess let's do this one next. Color result 2.14. My writing, no, my writing. Disjoint measurable sets. Not just any sets, they have to be measurable. Disjoint measurable sets. Then Oh man. Base step. Okay, guess I'm a little bit more. Should be more explicit actually. Okay, that's the base step, and then the inductive step. I can copy this, suppose. I can't really copy any of this. Or a set. Oopsie. It's supposed to be a sum. So P. Oh my gosh, I didn't even fix this. Oh shit. Okay. This is supposed to be P. This is P. This is supposed to be K. Oh man. Is that me or is this my app? It's K and this was P. Hmm. Okay. Okay. Right here. Hmm. intersect EK or EP plus 1. Okay. Okay. P. Show this. I show this. You think? Oh, not this. This. Um. Yeah. Why don't we just show it? Screw it. That's fine. Okay. What else did I want to show here? Okay. Since this is measurable, should copy this because I don't want to keep writing this stuff. My God, no. Okay, use circular parentheses instead. Intersect this one. Big ass parentheses. Fuck. What the fuck? The fuck Royden doing with this math? Fuck. That's what I'm trying to figure out. Oh my God. How you doing, Justin? Fuck, man. Okay. I should just copy this because I'm just gonna write it again, but with slightly different notation. Plus this. I'm good, just hanging out. UCS grind is real. Oh, you grinding for UCS for real? You got a team? Alright. Go. I need to take a page out of your book and learn something new. Yeah. It's always good to learn something new. Especially something in your general interest region. How's the patch? I saw you and Resi were playing on the night it released. Well, I fell asleep before the patch released, but I saw you guys were playing like the 2 hours before it released. Okay, this is playing against. This is also playing the rule of A. Oh, fuck no. This is not happening, bro. What is going on with my iPad? Oh my god, man. That's just bad. They basically put all the mons in a hat and drew randomly. Also, Darkrai is bad. Damn. I haven't seen much of Darkrai, but I was hearing that it was kind of bad. It's like too. I think I heard its combo was too slow. It basically just gets like one shot before it can release like a full combo or something like that. I don't remember if I heard that correctly. Fuck, man, look what happened to my notes. Fucking damn it, man. This is literally this area that I fixed too. Holy shit. I can't, man. This is so stupid. Basically, and the Unite gets canceled by everything. Oh, that sucks. I don't even know what its Unite does, to be honest. I honestly didn't see it. I almost didn't see any gameplay of it. I barely saw anything. That sucks. So you have a team, huh? Who's in your roster? And I'm missing out. Well, I do want to try the Machamp change. Now that they reworked its Unite, I want to try playing that, and I want to try playing close combat because of the buff. The buff. I used to actually play close combat more before I switched over to cross chop. So it's gonna be kind of comfortable for me. Me Pyro Miracle maybe. Oh, MQL and Mo. Interesting. Likely a roster change soon. Interesting. Who's the team captain? Fuck, man, I'm so mad about this shit. Fucking damn it. This is ignored for now. I don't know, I just worked there. I see. If I remember correctly, MQL is a top laner? Yeah. I remember when he first came into the scene, a couple people were shitting on him. Like Red Love. Forgot who else. Back in those days. Now he's established himself as a top laner. I believe it. I mean, to be fair, Red Love would always try to like shit on everybody. Plays the role of A. Red Love server was AIDS. Yeah. When did you get on the team? When did this happen? This is... Wait a minute. What did I get here? Oh yeah, this is for... A intersect E t plus 1. This is because... Oops. Oopsie. This... Um... And this... Where is it at? This... Um... There you go. And then this is a hypothesis. This is the hypothesis. Oopsie. It's the inductive hypothesis. Then that's just the same thing as this. Okay, I'm not going to rewrite everything again. Just copy this shit right here. By induction. Okay. This is corollary. Why? Why? Are you out of work? You like that one? That's a good one, huh? Finish my errands, cleaning now, and then I go to Sam's at 4:30. 4:30. Damn, you have a lot of stuff to do. 4:30 is 2:30. Maybe I go to Rock's class today. The measure of the union. Oops. I'm jumping the gun. I'm getting distracted here. Disjoint measurable sets. Then... Oh, I cannot fit it in here. Oh, no. Okay, what do I do? What do I do? The measure of the union. EK. This is a cool consequence. Okay, I need to move things around. This here. Then so I'll move this down. Hmm. $2.14. Paste. Change the color. Actually, use this. I'll just use this. Change this color. It's X. Easy. Easy peasy. All right. That was the disjoint stuff. What else do I have? I have another one. Guess I should move these down more. Okay. This one probably should have went earlier too. This could have been done way earlier. $2.15. Okay. Ah, so okay. Okay. One more for the paper. This is what, 15, 16? Proof of this is just A intersect X plus A intersect X complement. What was I going to do here? A Okay, I think that's good. Okay, I think I got everything I needed from this. Relabel these. This is going to be 17. C 17. 18. Okay. Did this. Did this. So I did intersections, I did set difference. I don't think it's even in this book. Is it even in this book, set difference? Set difference is a measurable set. Observe the definition of measurability is symmetric in E and R minus E, and therefore a set is measurable if and only if its complement is measurable. Okay, that's the complement, that's fine. What about the set difference? Oh, I don't see set difference in here. Oh, this book actually does this here. Interesting. The union of a countable collection of measurable sets is measurable. So I haven't done this yet. Every interval is measurable. Got the sigma algebra here. Okay, where's the set difference? There's no set differences? Collection. It doesn't even have set difference. That's so interesting. Why doesn't it show that? A collection of subsets of R is called a sigma algebra provided that it is an algebra and is closed with respect to countable unions by De Morgan's identities. Such a collection is also closed with respect to countable intersections. We have shown that the collection of measurable sets is M is an algebra, so it follows from proposition 12 that is a sigma algebra. Can I just define proposition 12? What's 12? This is countable union, and so the complement is measurable, and that's the countable intersections. Is it possible to define the sigma algebra without set difference? Maybe. Maybe. I need to check. Sigma algebra. Okay, sigma algebra. Sigma algebra. Actually, I don't need this anymore. A set X is a non-empty collection of subsets X closed under the complement. Countable unions and countable intersections. Yeah, countable. It's typically defined using the complement, but I think it's defined using complement and countable unions, and it needs to contain the empty set. A sigma algebra of subsets is a set algebra of subsets. Elements of the latter only need to be closed under union and or intersection. So it's either or, which is a weaker condition. Interesting. Okay, I'm a little bit confused about this requirement. Here it says closed under complements, unions, and countable intersections. But in the mirror book, this is defined as where is it at? Okay, that's a sigma. That's not sigma algebra. It's right here. No, right here. Yeah, it has to contain the empty set. It has to contain the complement. Oh no, the set difference. No, the complement. It has to contain the complement, and it has to have countable union. But these three imply intersection. Holy moly! Oh man! Oh. So far, I basically showed this already. I've showed this. I've showed this. I've showed this. All that's left is to show this and this. I don't know. No idea. Algebra. Sigma algebra. This is exactly the same definition. How does this guy define it actually? What is going on with this quality? It's right here. Hey fam, how you doing? I'm watching this. What's goats? It's Ghost of Tsushima. I, used to shorten it using GOT, but people were like Game of Thrones, so I readjusted the acronym. Okay, this is the same. This is the same definition that I've always used. Okay, so I guess there are different ways to redefine the sigma algebra technically, because technically these three conditions imply intersections and so on. So it's probably possible to redefine it a different way and then get some other ones and probably get the empty set as a consequence, and then what else? Yeah, the empty set as a consequence, because that was the main difference between the definition that I'm used to, which is this definition, um, and the definition in this book, which is not this one, but this one. This definition for sigma algebra um, is dependent on countable unions and countable intersections. So perhaps with these two requirements, if we start with these, you can get the empty set. You can get um, the complement. Wow, that'd be an interesting exercise, actually. Maybe for another time. Not something that I'm really too interested in. But um, something to note. Something to note between these two books. The differences between these two books is um, that it doesn't build measurable sets. This book doesn't build measurable sets. It actually builds. It works from this. It starts from sigma-algebras, and then it just says that measurable sets are sets in the sigma-algebra, which is true, but it can be shown that that's true. So it basically uses it as a definition. Where is the definition? This is Borel sets. These are Borel sets, so I'm way too far. Borel sets. Where's the measurable set? This is a Borel set. Okay. There it is. An element of S is called an S measurable set, or just a measurable set if S is clear from the context. So basically a set is measurable if it's in S. And S is a sigma algebra. So this book doesn't develop measurable sets, but Royden does. And I think this is really good. It's good to do this. It's very interesting. Okay. What else do I have left? So I did this collection of subsets of R. Okay, this was just a note from the book. Okay, what's prop 5? Prop 5, I was looking at the hard copy. What was prop 5? Prop 5 is the union of a finite collection of measurable sets is measurable. Okay. The union of a finite collection of measurable sets. That is, what is that in my notes? This is disjoint, so it's not this one. Oh man, this is like making me kind of mad looking at this. Okay, the finite union of measurable sets, that's 212. 212. Okay, I think I've kind of fixed everything. So I can now write what this result is. This is 19. This is 220. Did I even finish this? Yeah, no, I was in the middle of this when I was working on this. Okay. Okay. Man, this is so sad. I'll probably do this off stream, fix this again, or probably just restart my iPad and then fill in the details in here. Time is it? It's 1:02. Maybe what I can do is I can finish this last theorem, this last result, and then call it a day. Okay, what was I doing here? Okay, since this is measurable and E complement is a subset of E Fn complement, measure of A. Okay, this is the order. This is order preservation. Okay. Prop 6. And so by prop 6, what's prop 6 here? Prop 6 is finite disjoint collection. So by result, what's the disjoint? That was this one, 2.14. But I only just got here. Yeah. I'm sorry, but I gotta do stuff outside of streaming sometimes. Otherwise, I could keep going for a very long time actually, and not take breaks like Pomodoro. You know. Whether it sticks in my brain is another question. So 2.14. Okay. So I'm referencing my book, but my book is an older edition of the one that's on the screen. I want to see what it says on the screen. This is edition 10. Oh, interesting. I should probably put this definition in here too. The union of accountable. Okay, I'm on this one right here. I just did this. Are we going to get GMT, geometric measure theory, down the road? Who knows? It just depends. Depends on whether I have the drive, I guess. By the way, welcome, Principal Bundle. Have you taken measure theory? If so, what book have you used? Okay. By this result. Oh, sure, we used Terence Tao's measure theory. Oh, I forget about that book. For a qualifying exam in real analysis, and yes, I passed that a long time ago. PhD passes. Interesting. Cool, cool. Good fun times. Boland's treatment is most slick. Yeah, that's a blue book, right? I think it's a blue book. I have like a PDF of it, I think. Actually, let me see. Unfortunately, these books cost so much money, so I can only buy so many books. But I think it's this one, right? Yeah, I occasionally go through this book as like an extra reference if I need to if I need like a different quote unquote different perspective. Yeah, but this book is really good. I've liked the when I do look at it, it's like an enjoyable to look at. The generous library. Yes, I too get my books from there. Actually, all my books. I think all of my PDF books are from that website. Oh yeah, the Stein and Shikarsky series is good. Yes, specifically like the um the first book. First book is awesome. Where is that book? This one, the Fourier analysis. This book is great. Yeah, this is a great book. I kind of read half of the second edition, which is the complex analysis book, but I haven't looked at the measure theory stuff. That which is like the third edition and the fourth edition, I think is functional. I don't remember. PDEs. I can't believe it filters that. That's interesting. I know why it doesn't like the word PDEs, but I think it's kind of crazy that it still does that. The Taos book defines Lebesgue measurable sets as E, where for each epsilon greater than 0, you can take an open set U such that the set difference of U and E is less than epsilon, less than or equal to epsilon. That's interesting. Yeah, it seems like there's so many ways that you can define this measurable set. That's like the what you just expressed is like familiar to me. It's like a consequence I think that you can get um, after you define a measurable set a certain way. But I think it's interesting that you can define it in a different way and like get the consequence of the other definition. Yeah. It gives exercises to prove that they're the same notion. It's all good stuff. The later Stein's Fourier analysis stuff is a must reference for some people getting into PDs. Yeah, the Stein book is like I think like the best Fourier analysis book I've seen so far. I haven't seen a better one than Stein's. It's really good. And I just found out about it like recently, I guess. All PDs are filtered on Twitch. Yeah, I know. For a good reason. It's wonderful to see an analysis with Twitch channel. Thank you. I would like to see more people stream analysis, but it's not very common. There are math streamers on Twitch. A lot of them tutor or help with math. You've probably seen them, but some of them work on like algebraic topics or differential geometry. I'm not differential geometry, differential equations or complex analysis, from what I remember. I need to learn more analysis. I have to learn to enjoy it more. Honestly, I think analysis is like one of my favorite subjects to like work through. I used to like I used to be bad at it. I'm not saying that I'm good at it now, but I've improved a lot since since the since my undergrad analysis days. Like it's like night and day. And now that I'm like at this point, like working through like these problems or like the theorems and like filling in the gaps is like it's like a good hobby. It's like really fun. There's like a lot of set theory stuff that's not written down. There's like a lot of undergrad analysis that's not written down. Um, so it's like a good exercise. And yeah, it's like it's applicable for a lot of things, right? Like a lot of things in like physics. It's one of so many algebra channels on Twitch. Hey, you need algebra. You have to have algebra. Analysis offers a lot of fun little puzzles along the way all the time. I recently had to use the interval from 0 to 1 cannot be written as a disjoint countable union of closed sets. Bounded convergence theorem. Interesting. I actually never knew that. That kind of Brer category theorem. Brer category theorem. Yeah. I remember that. I actually did not know that until you said it, but I can see why. But I would never have guessed to use the Baire category theorem. Honestly, I kind of forgot about it because I haven't seen it since like at least 5, 6 months when I was like working through functional analysis. Honorable approach. BCT is awesome. It's an easy repurposing of compactness or completeness, but some of the implications are incredibly weird. I see. Actually, let me see. Let me try to remember what. Actually, let me show you what my version of Baire category theorem looked like. I don't know if it's always the same because I know sometimes the theorems look a little bit different from textbook to textbook, but they're supposed to be equivalent. Let's see, where was it at? Bear, where are you? It's this one right here. A complete metric space is not the countable union of closed subsets with an empty interior. Okay, yeah, I remember this. And the countable intersection of dense open subsets of a complete metric space is not empty. I see, I see. You look like John Nash, version 2. I look forward to your proving wonderful new results. Wow. I don't think I'll ever be that ambitious, to be honest, but I appreciate the optimism. Yeah, I actually really like this topic right here, these topics too. I spent a lot of time on this because it was like very topology like heavy. And I really like topology, um, like just topological theory in general. Good times. Okay, I have to finish this theorem now, um, and then I have to head out. I was choosing between algebraic geometry and PDE's topics, ended up going with the latter for a PhD in the end. The former was too rigid for my taste, but I did go through some Hartshorne, EGA, SGA stuff. I see, I see. I actually want to go through PDEs as like I want to go through PDEs too at some point. So I'm hopefully you stick around and help me out when I do help a poor lad out. There are so many different kinds. That's true. Yeah, that's true. I was like, I kind of wanted to go through kind of like the standard stuff for like the elliptical, the parabolic, and all that stuff. Like just stuff that's like something that will allow me to kind of breeze through some of like the applications in physics, like some of the standard problems in physics. That makes sense. And I guess enough for me to be able to like, um, I guess, um, be able to like program. Oh, interesting. Yeah. I found out that PDs are like there's like so many different kinds. I didn't even know until like a professor of mine kind of like told me about it. And it's like insane. It's insane how many different kinds there are. And my like initial impression was like, okay, there's like those basic like the wave equation and stuff like that, like all like those standard PDEs that you see in physics. I was like, I just want to like be able to see a PDE in some sort of like physical situation and be able to like numerically solve it. Yeah, it's a huge subject. Dang. So I guess it takes it can take like a whole PhD then to to get a full grasp of PDEs. It's not one of those like 1 semester, 2 semester type of things. What is this? What was I doing here? This is equal to this stuff probably looks like freaking undergrad analysis to you. Holy moly. Okay. To the sum. Okay, and this is just by the definition of Fn. And this is by 2.14. I just realized I don't have my music playing. I was like, why is it so quiet? Okay, that's obvious. And then there is the next line. Measure of A. This is equal to the sum right, yes. Okay, where am I? I'm like right here. The left-hand side of the inequality is independent of n, so oh, they're taking the limit. Okay, this is from limit properties. By by the measure of A is equal to the limit as n approaches infinity of the measure of A, which is less than or equal to, or which is greater than or equal to the limit Okay, so this is independent of n2. So this limit is just the measure of A intersect EC. And then this is by definition the sum from k is equal to 1 to infinity. But I feel like there's convergence issues. I always forget about this stuff. Because you can distribute the limit. So the limit is distributive if I think both of them are convergent. Where is it at? I need to like know this. These are like things that I really need to know by heart, and I just don't. Where's the distributive stuff? Whenever there's convergence issues, we usually use lim_inf or lim_sup. It's a sleazy man's trick. Yeah, I know lim_if and lim_sup are much easier to work with, but I haven't had a lot of practice with those, unfortunately. I need to go through it to like kind of understand, because I remember it's both of the lim_inf and lim_sups, if they're equal to each other, then it equals to the limit, if I remember correctly. Like it's related to the limit. But I know you can work with them outside of the limit. Suppose A and B are sequences such that A of n converges and A plus. Okay. So 25. This reminds me of an exercise where it's convenient to use lim_inf and lim_sup then. Suppose E1, E2 is in a sequence of Lebesgue measurables such that so that is Lebesgue measurable and that measure. Interesting. Maybe an exercise I can do some later time. Let me take a picture. Okay. All right, I figured it out. This is why it's convergent, and it's basically because of um, this. Where is it at? So I'm using 25. If A and B are sequences such that A converges and A plus B converge, then B converges. And so the idea here is that we know this is going to converge because it's a constant, and we know that the whole limit is bounded. Oh wait, bounded. It's bounded above by MA, and it's also increasing because it's a sum. So it's monotone. It's monotone. That's monotone convergence. I'll go play with Lexus. Have fun analyzing. All right. Have fun. I'll talk to you later. So, um, this, we need more analysis in Twitch, definitely. Yeah. I think slowly but surely there will be more. Maybe you can stream. Maybe you can stream analysis. Yeah, but we definitely need more. Yeah, but I think this works, right? The limit as n approaches infinity of m a ec is equal to just m a ec and paste. This is bounded above by the measure of a and also increasing. So the limit less than infinity by not Brer category theorem, but bounded bounded. So not Brer. Actually, it's MCT, not BCT. Monotone convergence theorem. Hence, this n approaches infinity of a intersect E K is less than infinity. And so now now we can actually distribute the limit. So copy, paste. This is actually greater than or equal to plus M A intersect EC. Oh! Oh, thanks for following. Sorry, I missed a bunch of messages. I was just like zone the zone. When you know algebraic overlords are trying to take over. Oh no! We need to fight back. I'm JK. I do use some basic facts about Lie groups and Lie algebras often enough. I need to learn about these. I skimmed over this stuff when I was like looking through basic representation theory. Here's a little algebra fact that I did make a lot of use of also. If V and W are vectors in R3 and A is a map from R3 to A3 is any linear transformation, then AV, the product of AV and AW is equal to the determinant of A times the transpose of A inverse. Oh my gosh. There's so much. If A is invertible and X is the cross product. Oh, I see. As a generalization, RD also bilinear pairing. Oh my gosh. Not the bilinear stuff. So in fact, if A is a rotation matrix, then it says that AV cross AV is, or AV cross AW, I'm assuming you're trying to say, is equal to V cross W. So it is a rotation matrices. So it is rotation matrices equivariant. In fact, this is how I was teaching cross product a long time ago to undergrads so that they can prove all the properties of cross products like right hand rule. Interesting. That's cool. Yeah, I gotta go see, keep up the analysis. Let's take care, principal. I'm just splashing around in the math kiddie pool. Hey, I'm in the kiddie pool too, man. We'll splash around together. It's the like just reading all that is just like I kind of like I vaguely know about all this stuff, but it's just like I've never gone through it in like fine detail. Like that's something that you probably would do if you're like in a PhD and in this obviously in this realm, but I'm not, you know. If you're in a PhD, that's your whole job. That's your job. Your job is to basically learn the details of this stuff. And it takes a long time. Unless you're very talented and a genius like Terrence Tao, then it'll take you like a fraction, maybe a year or two. But yeah, at some point I do want to know about all this stuff that Principal's talking about. Like this is like literally in the area of my interest. Oh, one of these days, you know. One of these days. Maybe I'll stream my whole process of growing. Okay, what was I doing here? Okay, we got the infinite sum enhanced by countable sub-additivity of outer measure. Ooh, that's cool. That is really cool. And so by countable countable subadditivity. By countable subadditivity, the measure of A intersect wait, no, not this. Not this, not this. It's this. It's this. Yes, yes. And that is less than or equal to the sum. I can write intersect EK. Right? That's countable subadditivity. I think that's in the previous section that I did, 2.2 somewhere. It's outer measure. It's the interval. Where's the subadditivity? Okay, there it is. So it's this. So we're basically using this, which is proved earlier. This is 2.8. All right. And then this is going to attach to this. So paste. And that is less than or greater than or equal to this. Plus the measure Okay. Okay, we're not quite there yet. I thought we were there, but I mean, we're basically there. But I just need to redefine this. I need to redefine that term. So since the union A intersect K is equal to A intersect the union K's, which we define to be E, That's exactly what we want. So the measure of A is greater than or equal to the measure A intersect E plus the measure of A intersect E complement. Good, good. Awesome. Thus E is measurable. Nice. That was good. I was scared a little bit for a second. I was scared about this. Or where is it at? This scared me a hot second because I struggled with this at one point, and now that I've done it a couple times, it's nice to know that it's getting a little bit faster for me. But it's not obvious. I feel like if you're kind of new to analysis, knowing to apply boundedness and monotone convergence is like not obvious. Okay.